Alright guys, we are going to do these notes on binary ionic nomenclature, and the goal here is for you to know how do I write names and formulas for binary ionic compounds. Okay, so let's start with some of these words. A lot of words here. Okay, first of all, let's start with this topic word, nomenclature. Nomenclature is a big old fancy word that means a naming system. Okay, so for example, in my family, the culture is to name your children after they get a unique first name and then they get a family middle name. And because we are Scottish, we typically use, so like my daughter, since she was the firstborn girl, she gets to have my mother's name as her middle name. Okay, a secondborn girl would get my husband's mother's name as her middle name. So there's a system, like there's an actual, like, this is how we do this. There's a reason, there's a why. And so nomenclature in chemistry is the system that we use for naming our chemical compounds. And it all depends on what type of compound it is. So let's start with the compound we're doing today. The word binary means two elements. Not two atoms, but two elements. So ionic, of course, we already know is going to be a metal and a nonmetal. So this is a very straightforward naming system where we're looking at simply one metal, one nonmetal. How do we write names for it? And then the reverse, how do we go from the name to the formula? All right, and there's going to be some stuff here that feels really familiar because we just talked about a lot of this stuff in our Lewis dot structure unit. So, to write a name. Whoops. So, the rule with this is the metal always comes first, then we write the nonmetal. Okay? When we did our Lewis dot diagrams, the metal always comes first, then the nonmetal. The rule really is that the least electronegative thing comes first, but in an ionic compound, that's always the metal. So, the first thing you do is write the name of the metal. Okay? The second thing you need to do is to write the name of the nonmetal. And you're going to change the ending to IDE. So, let's do a couple of examples of that. If I have Na3N, that's going to be Na is sodium, so I write the name of the metal, and then N is nitrogen, so I would write nitrogen, and then I'm going to dump the ending, so I'm going to get rid of the ogen, and I'm going to add in its place IDE. So this would be sodium nitride. Okay, let's do another one. Let's say I have magnesium and oxygen, MgO. Okay, this would be magnesium, name of the metal. And then we write the name of the nonmetal, which is oxygen. This one's kind of crazy. We dump a lot of this. We dump the igen, and we replace it with IDE. So this would be magnesium oxide. Okay? Fairly straightforward idea for writing the name. All right? Now, before we write formulas for this, we need to grab our periodic table and a Sharpie real quick. So let's go grab your periodic table and a Sharpie and join me as we add some things. Okay. So on our periodic table, we've already put our charges on here, right? Group 1 is 1 plus, group 2 is 2 plus, group 13 is 3 plus, group 14 is plus or minus 4, group 15 is 3 minus, group 16 is 2 minus, group 17 is 1 minus. Okay, now, thus far, I have failed to tell you just a couple little things. Now it is important to know this. First of all, these charges on the right, they stop right about there. They stop at the metalloids. Anything below the metalloids, that charge does not necessarily apply to. Okay? You remember me telling you how all of these guys kind of over here were funny weirdos? That's true. They are funny weirdos. And we're going to get into later this week the ones that don't have just one charge. They are called multivalent. It means that they can sometimes be 2 plus, sometimes be 4 plus, sometimes be 1 plus, sometimes be 3 plus. They're weird. There are 4 of them that do not participate in those shenanigans. And those are the 4 I want you to circle on your periodic table. Aluminum, always 3 plus, no matter what. Zinc and cadmium, right here, always 2 plus. Silver right next to it, always 1 plus. These guys do not participate in the shenanigans that the other ones are going to participate in, and we're going to talk about those ones a little later in the week, okay? But those 4, when they form formulas, they're going to do exactly what group 1 and group 2 metals are going to do, which is what we're going to talk about next. So let's talk about how to write a formula. Okay? When you're writing a chemical formula, we're going to do this just a lot like what we did with the crisscross thing before. Okay? So you're going to write the symbol for the metal. Then you're going to write, whoops, I missed the letter, there we go. Write the symbol for the nonmetal. And then you're going to do a crisscross of the charges. Similar to what we did in the last unit with ionics, but let me show you what I mean. Okay, so let's say let's use one of our special friends. We have aluminum oxide. Ooh, I did forget. Just like last time when we crisscross, if you can, you do reduce. Okay, so you crisscross and reduce. All right, so we have aluminum oxide. So the symbol for aluminum is Al. Symbol for oxygen is O. So if we go to our chart, aluminum has a charge of 3 plus, and oxygen is 2 minus. So aluminum is 3 plus, oxygen is 2 minus. Now, this 3 is going to come over here, doop, and become a subscript. This 2 is going to come over here and become a subscript. So this is going to give us Al2O3. That is my formula. Okay, let's do that again. Let's do another one, because this is a little more confusing. Okay, let's try sodium phosphide. All right, sodium symbol is Na. Phosphide is phosphorus, so that would be P. If we go to our periodic table, sodium is group 1, so it's going to have a 1 plus charge. Phosphorus is in group 15, so it's a 3 minus charge. So we're going to pick up this 3, put it on the sodium. The 1, we pick it up, but we don't actually write 1s. So this formula would be Na3P. Let's do one more real quick that we have to reduce. Let's do magnesium sulfide. Okay, this is Mg, and then sulfide is sulfur, so S. Magnesium's 2 plus, sulfur 2 minus. So we take this 2, put it here, this 2, put it here. But 2 and 2 reduces down. They're both divisible by 2, so this would just be MgS. Okay? Tomorrow we're going to just do a whole bunch of practice on this, just a whole bunch. So just come with your notes ready to go, and we will do some practice.